since we are not looking at them, again, I emphasize this, we're saying that the exemptions are very conservative in nature. And there is no evidence that the use of genetic engineering in and of itself introduces plant pest risk. Okay, so what are the three exemptions? The three exemptions for DNA modifications are double cellular repair of a targeted DNA break. So if you make a double strand break, if you get deletions or insertions as a result of that double strand break, and you don't provide an externally an external repair template, that is exempt. We have a modification where you can add an external template, but we're only allowing a single base pair substitution. At least that's what we're allowing at this point. And then we have an exemption that is broader, where if there is an exemption for cisgenic. So if you're introducing through genetic engineering a gene that occurs in the plant's gene pool, that would be exempt. Or if you recreate such an allele by using genome editing, as long as that variation is in the gene pool, that would be exempt. So those are the three types of modifications that would mandate exemption. Now, I emphasize how conservative we're starting out, but we also put in we realize that there may be additional modifications that can happen through conventional breeding, or there might be advances in conventional breeding that allow multiple modifications to be made to a plant species that we haven't captured. And so we have a provision in the regulation for the expansion of exemptions to cover additional multiple modifications into a plant species. This could be done APHIS can initiate it, or stakeholders can request that. And it'll be a process that involves public notice and comment. But the idea is to ensure that the regulation remains current with technology and science, but it also balances our concern that we did not want to go too far and undermine the basis, the rationale for making these exemptions, that the modifications could otherwise occur through conventional breeding. We realize it's very easy now to use genome editing to make multiple modifications, but we have to be convinced that those can occur through conventional breeding in order to make an exemption. We also have an exemption for what we call event-by-event regulation. So if there's a plant trait mechanism of action that has been evaluated and designated as not subject to the regulation, then any future plant trait mechanism of action that is similar would also be exempt from the regulation. We realize that developers may decide there to self-determine, but then they might want to seek confirmation from APHIS that the product meets the exemption. And we have a process for confirmations of exemptions. We'll answer the written requests in 120 days, and those confirmation letters will be posted on our website with redactions to protect confidential business information as appropriate. The extent of what's said in the confirmation letter would depend on what the request says. So if the request from on one extreme, we will say that you don't need to provide any information other than what you've done, and we will confirm that if you did what you said you did, that would be a confirmation, up to the point where you supply the data, you supply sequencing information, and we actually review that. So the letter will be responsive to the type of information that's sent in the confirmation request. So now we have another process, what we call regulatory status review. This is actually going to replace the petition process. If a developer does not meet the express regulatory exemption, then a developer can seek what we call this RSR to determine whether the genetic engineering is regulated or not. We are basing the RSR, we're trying to make this a much simpler process than the petition process in that we're not going to be requiring field testing. We're requiring a minimal amount of information supplied by the developer. It's based on the plant, the trait, and the mechanism of action. And we're going to be largely using the literature to evaluate the biological properties of the plant and that trait, and looking at how that plant and trait may create any kind of plant pest risk. So this new process will have a risk assessment that can be done. It'll be voluntary. I mean, some companies may just want to go under permitting without having us do this risk assessment because, quite frankly, there could be a bottleneck, at least in the beginning. But it does offer the opportunity, especially for small companies or academics who are not under as much of a time crunch, to get an answer up front. Even if you don't meet an exemption, you won't have to go through a lengthy regulatory process. So the RSR will consist of 2 steps. The first step is a more rapid review. We look to see whether or not there is any plausible pathway to increase plant pest risk. And if we don't identify a plausible pathway, that's the end of the story. That organism is not subject to the regulation. And if we do identify a plausible pathway, we would delve into a more detailed risk assessment. At that point, the developer can decide they don't want to go through the next few steps, complete this step. They can just withdraw, or they can obtain a permit. Or the third option is they can request that APHIS complete the second step in the process. So step 1 should take 180 days. Step 2 should be completed within 15 months. So we would look at the factors of concern to determine likelihood and consequence. So basically a much more complete risk assessment. Those results will be published in the Federal Register. There will be public comment. And if we find that there is not an increased plant pest risk, that plant would not be subject to the regulation. And if we do make such a finding, it will remain regulated. So I want to compare the risk. This regulatory status review has some similarities to a process that we're doing now called the Am I Regulated process. The end result will be slightly different. The analysis will be different between the AIR and the regulatory status review, but there's a similarity in that you don't need to do field testing, and it's based on a very small amount of information to get the answer. And I want to compare the AIR process and the petition process with regard to the total number of crops we've seen, the number of organizations, the type of organizations that have come in under the petition process versus the AIR process, and how this is evidence of that there have been a really big regulatory burden from the petition process. So if we look at the petition process, there was only one government petition, 5 academic petitions. This is over approximately 27-year period, and almost all the petitions were from the major biotechnology companies. And if you look at the total number of organizations in the last 5 years, it would be 19. And the total number of crops in the last 5 years has been 10. And if you look at the AIR process, well, we've got 39 academics versus 5. And other companies, 75, and major plant biotechnology companies are hardly even using this process. Only 6 AIR submissions so far. And it's really telling. The number of organizations is 3 times as much. The number of crops we're seeing is 5 times as much. So I think this is an indication of the type of regulatory relief we might expect to see. clearly there are a lot more academics and other companies who are using the AIR process, and we think that will translate into taking advantage of the regulatory status review and the exemptions. So what are the benefits of the RSR process? Well, it's a two-step process. We expect many of the reviews to be only need to go through that step one to give a fairly rapid response to the regulatory inquiry at the very early stage of the development. And this will save developers regulatory costs. It will increase regulatory certainty. It will help developers raise capital for their ideas and stimulate innovation. And for APHIS, we expect this to really help us focus staff resources and oversight on those plants and organisms that present the greatest potential for risks to plant health. I'm not going to go into this permitting slide to any detail, but we will have a permitting process. Those of you who are familiar with how we regulate plants might know that we had a notification process, which was a streamlined process that was often used by developers. That notification process is being eliminated. It was based on performance standards. If something needs to be permitted, we want to be able to have much better oversight, and we want to be able to prescribe the permitting conditions for those field tests. So let me just spend a minute or so on the implementation timing. So the rule became final in May 18th, 2020. As of June 17th, we no longer accept new MI-regulated requests. So they're going to be a phased implementation of the rule. So we're phasing out the MI-regulators. They've already phased out as of June. The August 17th is when exemptions will take effect, and APHIS will begin accepting confirmation requests. April 2021 is the date that we are going to start this RSR process. And so we're only going to be doing the RSR for a few crops: corn, soybean, cotton, potato, tomato, and alfalfa. Those few crops represent about 90% of our field trials now. The permitting regulations will take effect, and the notification process will be discontinued as of April 2021. And then October 2021, then the RSR process will be fully implemented for all crops. And at that point, we will no longer be accepting any petitions for non-regulated status. The phased implementation should allow developers adequate time to make changes to the business processes and management information systems to comply with the secure rule. So just a summary of the secure rule will allow APHIS to better focus its resources on protecting plant health. It will likely decrease unauthorized releases. Many of our releases we have now are for organisms that create no plant pest risks, and those will be most likely either exempted or quickly determined to not be have regulatory regulatory oversight. It will reduce costs for developers and spur innovation, and likely facilitate the availability of new varieties of crops that are safe for plant health and currently not available, such as vegetables and cereals. As I mentioned, we're getting many, many more vegetables and other type of crops in the MI-regulated process. We think we'll get that here as well. We have extensive communications with our stakeholders. We have an aggressive schedule to meet with regulatory counterparts around the globe, a commitment to connect with key trade show, grower organizations and opportunities, and technical webinars to focus on the implementation details. And the next webinar is on August 5th, which will talk about how to, about the confirmation process and what kind of information we need in that regard. I think this is my last slide. Thank you.
colleagues. They always make my life easier when I have to explain what I do and try and explain some of the overlap. As you heard, there's overlap between the three agencies. And I'm here today to talk about genome editing in animals, but I would also like to mention, and Eric brought this up as well in his talk, that FDA also has regulatory oversight over genome edited plants. And that would be through our Center for Food Safety and Applied Nutrition, who evaluates the food safety of plants. So USDA looks at the plant pest risk, and CFSAM would look at the food safety evaluation. And then also CVM is also involved with regulatory oversight for genome edited plants that are used for animal feed. So I just wanted to clarify that up front. I know it's not always entirely intuitive, but there is, sort of the products are spread throughout the different agencies. So I'm here today to talk about genome editing in animals. And I'm going to explain a little bit about our science and risk-based framework and how we regulate those products. So my division is the Division of Animal Bioengineering and Cellular Therapies at the Center for Veterinary Medicine. And my division doesn't only look at intentional genomic alterations in animals, which is what we refer to any sort of alteration, whether it be through an older technology or something like genome editing. We also look at more of the regenerative medicine space, so animal cells, tissues, and cellular tissue-based products, as well as some other biologically derived products, such as the crude tissue products. So we work very closely, as you've heard, with other agencies. We also work closely within our own center through different divisions that support my division, such as, evaluation of food safety. Also, Eric mentioned that we are subject to the Federal Food, Drug, and Cosmetic Act. We're also subject to NEPA, which is the National Environmental Policy Act. So we also have a separate division that evaluates the environmental component to these products. So we have a lot of collaboration across the center. And then we also work with our human centers as well within the FDA. So not only do we, look at genomic alterations in animals intended for food, but we also look at genome edited products that could be used for biomedical purposes. So for xenotransplantation, as well as, like the biopharm types of products where you're making a human drug device or biologic through the animal. Within my division, we have a group of 16 people, and we have a wide range of expertise, as you see here. I'm not going to go through that. And as I explained, sort of what we mean by intentional genomic alterations. So that would be anything that's produced. We don't look at the method under which it's produced. We look at the end product. We call it all the same thing. It's a genomic alteration, and that can be produced by something like a recombinant DNA construct, which was, I think, used more widely before genome editing. And now genome editing, we're seeing applications using talons, CRISPR, and some zinc fingers. There's also, as I mentioned previously, various intended uses. So it's not just for food production. There's also a lot of great work that's being done in academia right now to target disease resistance. There's work being done to reduce allergenicity in humans. And then, as I mentioned, some very important biopharmaceutical applications. So as Eric mentioned, we work primarily under the Federal Food, Drug, and Cosmetic Act. And according to that act, our charge is to ensure that what we call an IGA, or an intentional genomic alteration, is safe to the animals to which that alteration is made, safe to anyone who consumes food from those animals, and that it's effective, meaning that it does whatever the developer claims it should do. And that seems like a relatively straightforward thing, and it can be if it's a relatively easy to identify phenotype. You're changing coat color or something rather simple, but something like disease resistance, it may not be as visibly evident. And so, we really evaluate to make sure that that resistance is in fact what the developer is claiming. So we use a science and risk-based approach. So what that means is the data requirements are decreased based on risk. And you heard the other, my colleagues from USDA and EPA mention exemptions. We don't have exemptions under our law, but what we can do is exercise enforcement discretion, meaning that we don't enforce approval requirements for certain products that are found to pose minimal risk. And we have examples of where we've done that with the glowing aquarium fish called glowfish, which I'm sure Perry knows, as well as animal models of disease. And we're also exploring other categories that would be intended for food. So some of the things that have been mentioned, if it's something found in nature that has a history of safe use, that is a product that could potentially pose minimal risk. And so we're looking into expanding enforcement discretion for those types of categories. When I say it's based on sound science, we're constantly looking at the scientific literature. We're constantly looking at data that's provided by developers, and we're reassessing the state of the science as we continue to better understand the potential hazards that could be introduced by a particular technology and to better understand the risk profiles of potential products. So when we do our review process, so both for enforcement discretion, as I mentioned, which is that lower reporting category, as well as an approval, we look at certain risk factors. And before I get into this, I'll talk a little bit more about the process for those two categories. So for those lower risk tiers, or what we call enforcement discretion, we have some cases where we don't look at any data, and then we have some cases where we look at certain data up front, sort of akin to a consultation type of process, where we evaluate the data and we make a determination whether we agree that the product is low risk. And those assessments are done in 180 days, so it's a really quick determination. And we're looking to see some of these questions, which I'll outline in just a second. For the approval process, it is a stepwise process. However, there's a lot of overlap in between the steps or the various pieces of an approval. So some of the aspects would be molecular characterization. There's phenotypic characterization. There's food safety. I mentioned environmental impact and effectiveness. And it sounds like a lot of different steps, but when you look at it as a big picture, there's a lot of overlap for the steps. As you can imagine, a lot of information, for example, from molecular characterization showing what a particular alteration is, whether or not there's a new protein expressed, can impact another section such as food safety. And so we're able to leverage that information across sections, and data can either be submitted in parallel, or we can apply, if a developer chooses to submit in a stepwise fashion, we can apply what's already been submitted to those other steps. So some of the things that we look at is, we look at the alteration itself, and we look to see, are there any hazards introduced by that alteration that might impact safety, either safety to animals, to humans, through, or food safety through human consumption. We look at the alteration on animal safety, and I get a lot of questions about this. How do you evaluate animal safety? We get a lot of questions about unintended alterations. If there's unintended alteration present, that doesn't necessarily mean a product is not safe. If something is identified in the molecular characterization step, we essentially rely heavily on the animal safety information, which is essentially the health of the animals in comparison with animals that do not contain the alteration that are treated under similar conditions, and we call those comparator animals. As I also mentioned, for something like food safety, an important question is, are there any new proteins being expressed that could impact the toxicity of the product to humans? Does it increase allergenicity, and so forth? And then what is the impact of the alteration on the environment? And that's part of our NEPA analysis. And then the last piece I mentioned with regards to effectiveness, does it do what is it intended to do? So for our review process, we do allow for alternative strategies. A lot of people read the guidance that we have and think that that is a requirement. That is not the case. A guidance is a recommendation, and developers can bring forth whatever strategy they would like to with appropriate justification, as long as they meet our standards for safety and effectiveness. So we do allow for alternative approaches to data for multiple generations. That's been a place where we've gotten questions in the past, whether it's needed to have data for multiple generations, and it's not always needed. So we're always open to alternative approaches. And then someone, I think in a previous talk, mentioned multiple alterations. It's a very important aspect. So it's very important in multiple sort of areas. This is a very important aspect for xenotransplantation products, where a lot of times developers are stacking certain alterations to knock out certain proteins that may help improve the reaction of the human to transplantation. As well as, I know this is a very important area for producers, and those who want to have multiple phenotypes introduced into the animals that they're raising and producing. And this is something that does not, we get the question all the time, does this mean we need multiple approvals? That is not the case. If there are multiple alterations, that can be handled under a single approval. If we've already made a decision about something, whether it be through enforcement discretion or through an approval, then there's no need to come back in and ask for a new approval or new decision once that decision's been made, even if you're adding an alteration. So we base our decisions, as I said, on current scientific evidence and reevaluate our approach when needed. And that's where the flexibility comes into play. Maybe there's some information that's available in the scientific literature that we're not aware of, and you would like to propose something based on that information. We're always open to those discussions. With regards to timing, I know this is very important to everyone. As I mentioned, under the enforcement discretion evaluations, those are 180-day review periods. For approvals, we are working under timelines that are negotiated according to our Animal Drug User Fee Act. And so those are timelines that are negotiated with industry. So industry helps set those timelines, and then those are agreed upon by Congress. And typically that's a 180-day review time for a major data submission under the ADUFA timelines. So as I mentioned, a phased review is sort of that stepwise fashion I was describing in terms of data submission. So a lot of times developers in this space are either new or they're working with limited resources and they're unfamiliar with the process. A lot of times developers choose to submit data in a stepwise fashion, and therefore we get the data whenever they generate it. So there can be significant time lag between when a sponsor completes one aspect of an approval and before they get to the next. A lot of it's dependent on their own resources. Another thing that can also be very confusing with regards to timing is the date a file is opened with us is not necessarily the date that data is submitted towards an approval. Recently, since I came on board, we've developed a new file type called a veterinary master file, where we work with developers in that early sort of development space. And that's typically where those interactions and data are stored until the developer is ready to work towards an approval. And at that point, they transition to the INAD. Prior to my time, that file was not available. And so oftentimes developers would approach FDA early, which is what we encourage. And sometimes it would take up to 10 years before data would actually be submitted towards an approval. Other factors is product complexity. Are there certain things that can delay decisions related to complexity of a product, questions that arise, environmental risk, as well as public participation. Whenever the public is involved, it takes quite an effect on the timeline, in that you have to consider the public's participation in their comments throughout the process. So I mentioned working with developers early on. This is another thing that I've tried to do since I joined the group, is find more ways to help developers to understand what the process is and to really give them that hand holding that they need. And I think we've been able to do that quite well through our new veterinary innovation program, also called VIP. And that's available not only to intentional genomic alterations, but also, like I mentioned, that regenerative medicine type of space for the cell and tissue-based products. And this would be for any product that provides a benefit to animal or human health, food production, or animal well-being, and those that are going towards the approval process. We currently have 20 sponsors enrolled, and you can see here some of the benefits. Like I mentioned, it really is a lot of hand-holding. It's a lot of walking sponsors through the process, which doesn't always occur in more of the traditional type of product space. So, we allow for sponsors to send us information before they formally submit it. We'll take a look at it. We give them feedback. We tell them, maybe you want to think about adding this, or, making adjustments to this. And then they don't, that way it avoids them sort of getting kicked out of the queue with an inadequate submission. And so they come to us, they're prepared, and they know what exactly we're looking for. In terms of transparency, this is also another goal of mine, is to increase transparency in this space. We have recently published on our website the products for which we've made enforcement discretion determinations for. And this is that process that I mentioned, that we do that initial data evaluation up front, and then we make a decision whether or not we agree that the product poses minimal risk and therefore an approval is not required. And these are the examples of all of the products we've done that for. With regards to transparency, as well as what I was saying, my own goals in terms of really working with people, getting people to understand our process. We have a lot of work that's being done in terms of outreach. I attended a AVMC meeting last fall, and I got some feedback that developers and a lot of people in academia were unsure about the data requirements. They've listened to me talk, but they don't understand, like, what does FDA really need from me? And so it's really difficult in these types of discussions to outline the specifics of that information. But what we've done in response to that is to develop hypothetical case studies that go through the data expectations for certain types of products. And we'll be presenting that in a webinar this fall. And what we hope to get from that is feedback. So we want feedback about the process. We want questions. We want, challenge us. Is there a different way that you could submit data to address that question? And that's really what we want. We want that interaction. to work with our developers, our sponsors, and to really meet their needs. And so we also plan to follow up the webinar with a series of meetings to have those types of crucial conversations. I will say we tried to do this earlier this year, and we wanted to do in-person meetings. And I think you all know the challenges with in-person meetings this year. So unfortunately, those have been pushed off because of COVID-19, but we're really excited to start that process this fall. And with that, I will conclude, and I don't know if you want to take questions now or save them to the end.
I think what we'll do, Heather, first of all, thank you very much. Eric, thank you. And Neil, thank you. Let's take a 5-minute break, and then we'll resume at 2:40 with the producers and growers, and then have a Q&A session that can be inclusive for all of you. Does that sound good to you?
Sounds good.
We'll see you back at 2:40.
Good afternoon, ladies and gentlemen. My name is Donnell Brown. I'm a 5th-generation rancher and food producer in north central Texas. I'm following in the footsteps of my great-grandfather, who was one of the first to own and manage a commission company at the historic Fort Worth Stockyards. His son, my grandfather, moved 2 hours west to now our home in Throckmorton. And my father, born and raised here. And I'm thankful for the opportunity to work side by side with my parents and with my sons in an environment that is ever changing. It's never moved this fast, as the change paradox says, and it'll never move this slow again. The mission statement for our family business is very simple, and that is that we are continually striving to improve the efficiency of converting God's forage into safe, nutritious, and great tasting beef to better feed this world. We developed that mission statement decades ago, and it is with that mantra. That's why we are in the cattle business, and we love what we do. In that mission statement, I mentioned forage, and I'm talking about the forage that is produced out here in the rugged parts of terrain where it's not logical or really reliable to produce human food. Places where it's too steep, too rough, too rocky, too dry, or too wet. But we can produce grass, forages that can convert that into high quality protein in the form of beef. We've been early adopters of technology for generations. We started using artificial insemination the year I was born, and for 51 years have been artificially inseminating every cow on our ranch to the best bulls in the business so that we can produce thousands of offspring from the very best bulls to create more consistency and more uniformity. Our industry developed metrics to measure genetic improvement, and through tools like you guys help produce, we've been able to mass multiply those superior genetics and make faster genetic progress. We started using embryo transfer on great females like this back in 1981. And this particular cow is a special cow we know as Abby Grace. Those are my 2 boys holding that calf, her first of 400 calves that she produced as a result of embryo transfer and later on in vitro fertilization starting in 2006. Today, in the last 4 years, we've invested in feed efficiency technology, where every calf born here gets an electronic ID so that we can trace those animals, track those animals, and measure every bit of feed that they consume. And we're seeing huge opportunities to increase the productivity and the efficiency of these cattle. With each test, it's amazing to see how we have animals that eat half the amount of feed that gain still at the top of the production of their contemporaries. You know, the reality is that we're a traditional business in agricultural food production, and we don't have to change. But the other thing is, we will have to compete with those who do. And that's where I look at gene editing. We are excited about the future, and I want to thank each of you for what you do to help create technology that we as producers can use. I envision a day when we have cattle that are more genetically adaptable to these hot, humid environments, with a slick-haired gene or other things that make them more adaptable to an ever-changing global environment. I look for the day we can naturally dehorn those cattle. We did it with Angus genetics for years, but now we can do it through gene editing. I look for the day that we make them more resistant to parasites. We also boost their immune systems to make them healthier, just like you and I want for our children. We look for that to stay healthier so that we can have less labor, less vaccines, less antibiotics, and a more wholesome food supply.
Thank
We want to
you,
improve
Donald.
Donald?
sustainability. Yep.
We're going to have to move on. We're online, so it's all choreographed. But thank
All
you,
right.
and we'll have more time at the Q&A, but we'll get Chloe to take up the reins here, so to speak.
Sounds great. Thank you.
Unshare your screen.
Edited products. First, though, I'll tell you a little bit about Calyxt and what we do. And the first thing I have to tell you is that since 2017, we are a publicly traded company. So I have to share these forward-looking statements, essentially saying to please not make any financial investment decisions based on what I'm about to say. So the technology that we use at Calyxt is the Talon technology, which was developed in part by Dr. Dan Voitas, who co-founded and also is our Chief Science Officer at Calyxt. And he also gave the Plumber Innovator keynote talk yesterday. The products that we develop, so Calyxt is really a technology platform, and we focus on developing products with healthier and more sustainable benefits. And the products we develop are really focused in three key pillars: wellness, plant-based proteins, and sustainability. So we use the Talon technology. There's several ways that you can use the Talon technology in, and the way we use it, though, is basically to result in a simple gene knockout, which means their products we develop contain no foreign DNA and could essentially be obtained through conventional breeding. This, from a regulatory perspective, as you might have gathered by now, is very interesting, since it leads to a more straightforward risk assessment and regulatory data package. So a more straightforward regulatory data package also means that we're able to bring consumer-focused products and sustainability benefits faster to market. Calyxt is the first company to have launched a gene-edited food product, and we launched that product, which is a high oleic soybean oil, in March 2019, so just last year. And Dan Voitas also mentioned that product in his talk. And the way we launched this product is we first consulted USDA under the now obsolete MI-regulated process, and we also consulted FDA and got positive responses from both agency, and then launched our product. The US biotech regulations are a global reference, and that's really important because for gene editing, there are still many countries that are trying to shape up their regulations for these new products. So you see the map that I have here on the right. There are countries that are in green or lighter green. Those are countries that have already developed a more pragmatic approach to gene-edited products. You also see countries that are yellow, even orange or red, and those are countries that are still a lot more unpredictable in terms of their data requirements and the timing that they will apply on gene-edited products. Harmonization of global regulations is really, really important because otherwise this leads to asynchronous regulatory approval, which really complicates things on the global trade seen. So what are the regulatory opportunities and the regulatory asks? The first thing I want to mention is that US regulatory authorities have a solid history of bringing safe products to market. And this is really important and translates in those US regulatory authorities being recognized as credible sources of information by consumers. This means that consumers trust US regulatory authorities, and this is foundational. What are the asks that Calyx as an industry has from regulators today? We would like regulators to communicate more about the benefits of gene-edited products, and realizing obviously that there's only so far that they can go, but we know that there are several examples, and I'm thinking Impossible Burger or Perfect Day, that show that consumers more readily accept biotech products if these products have perceived consumer benefits. Secondly, it's to help consumers better understand products and really put things in perspective. So if you think of traditional breeding, which has decades, or it has existed for centuries actually, and has a history of safe use, but yet generates a lot more genetic variability in the plant genome. But because of those multiple rounds of selections, results in safe products. What we're doing essentially with gene-edited products is a very targeted gene edit, and also with several rounds of selections results in safe products. Third is to continue to keep pace with the rapid innovation and new product opportunities. And conferences like these are key to ensuring that and enabling that. And for regulators, what that means is that they're able to ensure that their regulations stay relevant. And when we're seeing some current changes at the moment, which is also really exciting. And finally is to continue to positively influence on the global regulatory landscape, because that is also key to continuing to enable global innovation. And with that, I would like to thank you very much.
Thanks, Chloe. Next up, Harry, do you want to introduce Mark?
Thank you.
Mark, you're up.
Good. Thanks, everybody. My name's Mark Platt. I am the president and CEO of Recombinetics. It's great to be with you today. We're located in Eagan, Minnesota, and our business is gene editing in livestock cells. We do that through 3 subsidiaries, 2 in the human health and therapeutic side of our business in Recombinetics, called Regenavita and Surigen, and the one that's most affected by what we're talking today is Excelligen on the livestock food animal side. So at Recombinetics, that's what we do. We edit livestock cells. So we're a business working to commercialize animals with intentional genomic alterations. We have a long track record of producing healthy animals that can advance innovation in both the biomedical and the food animal space. And in the food animal space, we currently have partnerships not only in the US, but we have partnerships in, and I wish my slides would advance. You're going to just get this for now. But we do have, there we go. And we do have partnerships, as I mentioned, in Canada, South America, Australia, Europe, and South America. So in the US, our business is heavily affected by the US regulatory environment, as you would suspect. Our customers and our investors need to be confident in our ability to get our products to the marketplace. And so our ability to compete internationally is as well affected by the US regulatory environment, primarily because as a startup company, we have been in Eagan, Minnesota for only a year, but we've been in the Twin Cities since 2008. We're still a startup, and we still rely on the capital markets, and the capital markets view of the regulatory environment here colors everything we're doing, not just what we're doing in the United States of America. So we have had some great success in the FDA approval process in our biomedical models of human disease. We have several approvals in place. Heather had a couple of them on her slides. Thanks, Heather. In the food animal area, where we haven't had any approvals yet, we still do believe we have a great opportunity to win together. There is clearly a public perception that we run into that the U.S. approval process for animals with intentional genomic alterations is uncertain. Most concerning from our standpoint in that area is the significant number of potential investors, as we rely on the capital markets we've spoken to, simply don't believe through their own analysis that the U.S. will approve gene-edited animals in a framework that'll be both timely and practical for the American farmers and ranchers. And this belief creates risks that much of the capital market just isn't willing to take. Additionally, we are part of a competitive worldwide industry where other parts of the globe have simplified and streamlined their own regulatory process of gene-edited animals. Brazil, Argentina, Australia, and they're positioning themselves to advance their own animal genetics using the tools that many of us here have invented and perfected. So we need to find a balance. I think we all have agreed that we want a science-based risk assessment for intentional genomic alterations. We certainly need to ensure that the safety of our products for the consumer is there. We need to ensure we understand the impact on making healthy animals. And we also have to find a way to do this all in a way that ensures that we are creating an environment that drives innovation and encourages innovation in this space. That's the balance we think we need to achieve. We do need clarity around how our gene-edited animals eventually find their way into the market, clarity in the specific steps. So thanks for what Heather's doing this fall. That'll be very helpful, including knowing, what the required data is going to be and what ongoing oversight looks like. Especially in our case, for, again, those genetic alterations that are not novel, they're not transgenic, and could be accomplished through traditional breeding if given enough time. So with that, we do have tremendous tools available today. We are in a critical season for genetics in food animals, not just for us as Recombinetics, but for anyone who's leading right now or wants to continue to lead in the animal agriculture space. It's a global game, and for those scientists and regulators who learn to safely leverage this incredible potential, there is a tremendous opportunity to do a lot of good, to help people like Don, to help the economies grow, and not only to improve disease resistance, to enhance the animal welfare, but ultimately sustainably feed a growing world population, which is really important to us at Recombinetics. All problems, there's no other technology that can fully resolve. So we are really looking forward to continuing to work with U.S. regulators to find our path forward and to win together. So thanks for your time, and I think that was pretty close to 5 minutes.
Great. So now we're going to watch a pre-recorded video, which was created by our final producer, Tom Rashi. And should be seeing this here.
Good afternoon. My name is Tom Rashi. I'm the Chief Technical Officer for DNA Swine Genetics. Pleased to have the opportunity to visit with you this afternoon about the use of gene editing in swine populations. DNA Genetics, as I mentioned, is a producer of improved genetics that services approximately 40% of the combined U.S. and Canadian market. This would ultimately represent about 40 to 50 million market animals in the U.S. and Canada that are influenced by our genetic program. In addition, we also have some international operations, specifically in Spain and Brazil. And I mention this because as we talk about the regulatory environment later in the talk, this will become important. If we look at swine breeding schemes, you can look at it in terms of a pyramid. At the top of this pyramid is the nucleus system. The nucleus is where the purebred animals reside. This is where genetic improvement takes place. And then it proceeds through a multiplication layer that contains two different levels, daughter nucleus and multiplier. This is where these purebred animals are multiplied in number in order to get to sufficient volume to produce the parent animals that ultimately service the commercial system. In our case, this would represent about 7,000 sows. This layer, about 100,000 sows. And if you look at the US and Canada combined, there's about 7 million sows that are in commercial production. I illustrate this just to show how genetics flow, as well as the size and scope of the number of animals that we're working with. Another piece of context is the fact that we do measure phenotypes on over 200,000 animals a year. Following measuring the traits and going through a genetic evaluation, those traits are placed into an index. This represents the index for our maternal lines. Each of these traits contributes value to our customers, and we're making genetic improvement in every one of them. Therefore, a novel edit would have to fit within this context, and we have to have an efficient way to put that into our program without slowing down the progress in each of these other traits. So where does this leave us in terms of regulatory considerations? Some things that will be important for us is that if we produce an edit in one of our animals, tracing that through that entire pyramid at the size and scope and scale that we deal with is going to be a very difficult challenge. It will greatly inhibit our uptake of the technology, and therefore approval should really result in a product that's deemed safe in all circumstances and does not require that traceability. There could be exceptions to this for specific purposes, but overall, we need a process that results in a product deemed safe. Also, when we look at the cost of this approval, the average profit margin for a pork producer over time has been about $7 per pig produced. So we need to think in terms of adding value to these customers, but in terms of cents per pig increased cost versus dollars. And if the regulatory expectation is prohibitively expensive, it's not going to fit within the cost structure of the livestock industry. And lastly, as I mentioned earlier, we do work internationally. And so if regulations could be internationally compatible, that will also increase the uptake and use of this technology. And last, I'd like to touch on implementation considerations. One of the challenges I mentioned is being able to incorporate edits in flow, if you will, in our breeding program in order to establish those edits in the nucleus. To do this, we would have to select animals based on their genetic merit, perform edits within the embryos produced by those animals, implant those embryos on a weekly basis on hundreds of cells and embryos from potentially multiple edits. Today, I would argue that the supporting reproductive technologies need considerable investment for us to be able to do this. They're simply not reliable enough, they're not efficient enough, and those would be things like IVF, cloning, and embryo transfer. And lastly, once those are further developed, they need to be able to scale to the level that we'll need to distribute these potential opportunities throughout not only our nucleus, but downstream in the other parts of the pork production system. So I thank you for your time and look forward to further discussion.
Great. So now we are ready to open up the Q&A. So feel free to continue to ask questions.
So we have one question already, but we certainly have time for many more. The question, and I'm for everyone who's regulating, the question, are there any unintended alterations that might impact safety? Seems to be asking a question where the answer has to be no, but that means proving a negative.
I'll take that first if it's okay.
Sure.
All right. So this was in my slide, so I'm assuming it was directed at me, but I'll give others a chance to respond as well. So we don't think that essentially it's proving a negative. That's why very carefully I don't state that there should be no unintended alterations. It's more of just looking at the hazards that could be presented that could impact animal safety. So for example, if you have a template that's integrated into the genome mistakenly, or if you have, some sort of near target large scale deletion or something that is identified at the molecular characterization stage, could that impact animal safety? It may not, and that may not be an issue, but it's not proving a negative because essentially we're not saying there can be no unintended alterations. And nor do we expect that detection methods that are currently available are able to detect all unintended alterations.
Another question has come in. Is an INAD required if you submit a VMF? And you might explain those initials.
Yeah, I'll take that one as well. So for people who don't know what the acronyms mean, we use acronyms a lot in government. I apologize. INAD is an investigational new animal drug file, and a VMF is a veterinary master file. And it's essentially just the administrative tools we use for our process. So an INAD is reserved for the approval process. A VMF, we use that for all early developmental work. We use that for those enforcement discretion determinations that I was discussing. So the INAD is reserved for the approval process. And actually anything that you're requesting, that would be an action under an INAD. So there are certain actions like requesting a food use authorization that would have to occur under an INAD.
Did we address this first question earlier?
So Heather, I'd like to put in a plug that even though it seems like there are all these restrictions and regulations and things like that, that the FDA has allowed the sales of tens of millions of genetically altered aquarium fish. And you certainly, the history of that, which I lived through, was that overwhelmingly at the time, the public response was largely negative about allowing these GMO animals out, but that the FDA used its regulatory discretion and the science behind the fish to say, well, actually, they don't pose a risk to the consumer in any way. Can you maybe elaborate on and you just mentioned the discretion that you have that an unintended alteration might still be okay if it's deemed not to pose a risk. Can you elaborate on that?
So Perry, let me clarify the question. Are you referring to specifically what makes the glowfish low risk, or are you asking more about unintended alterations and how those impact low risk products?
I'm asking actually about the processes that you go through in giving discretionary approval to things that might superficially look like they would be deal breakers.
Got it. Thank you for clarifying. So, we look at the product, we look to see, are there, and going through those questions that I presented in my talk, is it something that's intended for food? Is it something that is, something that has certain environmental concerns? Does it pose, any sort of animal or human safety concerns? So looking at that, you can get a pretty good idea whether or not something could potentially pose minimal risk. And we ask for certain data up front to confirm that in some cases, just as we've done with the glowfish, where essentially they send us limited data on molecular characterization, animal health data, and some of those aspects that I was mentioning. And then from that data, we make that determination that whether or not we agree if it's low risk. And you saw the numbers of examples where we've made that decision.
Okay, so we have a lot more questions flooding in now. There's a question for Dr. Lombardi. You mentioned that the FDA looks at the end product, but not the process. Does it mean that if the end product is identical to wild type organism, there is no regulatory oversight, even if the process of creating the wild type organism might involve transgenic organisms?
So it's a very good question. Thank you. So when I say we look at the end product, not the process, I feel like that requires a little more explaining, and people throw that terminology around and it's not always well understood, including by even myself in certain cases. So we look at the end product and we look at the risks associated with that particular end product. So we consider the process and any hazards that may be introduced as part of that process. I can't remember, sorry, can you read that again about the conventional breeding and something about transgenic? I can't see it.
You mentioned that the FDA looks at the end product, but not the process. Does it mean that if the end product is identical to wild type organism, there is no regulatory oversight?
Thank you. That's the part I couldn't remember. So what I mentioned before, that if it's something that could be equivalent to something, a wild type, something that is naturally occurring, that could have a history of safe use, that could be a basis for saying that product poses low risk. So that could be, something that could be considered as a low risk product.
Okay, so I have a question for Donnell and Tom. What are your views on cell-based or lab-grown meats? Technology is advancing quickly in this area, and there appears to be a market for the product. Scale is aging to continue to drop production costs. How will you be able to adjust if margins are already so slim in factory farming?
I'm going to let you take that first.
Thanks, Donnell. It's a good question. I think it's difficult to answer. I personally believe in the way that we produce pork, and that's the industry that I'm in, is going to be a product that is going to be in demand in the future. Production costs are what they are, but it's similar to cattle. I mean, it's a way for us to convert products that are produced by our farmers into a wholesome, product that people enjoy, and it's safe and it's healthy for them. I think with these other products, there probably will be a market for them. It's going to take a lot of scale for them to get to the same cost of production. I can't predict that. And I honestly don't know what the perception of the public's going to be. And what we're talking about today with intentional edits and so on, that same question exists at some level. So what is the public perception of an unnatural product going to be? So I don't know if that specifically answers that question, but I believe in the future of our industry. I believe in the future of the beef industry and poultry, and those products are going to be here for a long time.
Donald, do you have anything to add?
Yes. First, I want to amend the last couple of words in that question, in that really we need to call that family farming, because that's what we do as families in food production. And what I wanted to close my statements with earlier was that, in 70 years, we're producing the same amount of beef with half the number of cows. That's how much progress we've been able to make in just 70 years. And with gene editing, I'm confident we can hit fast forward on that genetic progress pace to get the cost of production even lower, where we can improve the sustainability, reduce the methane, reduce the carbon footprint of animals, and continue to use byproducts, co-products, and grass that you and I and chickens and hogs cannot utilize, and convert that into high quality protein that's needed around the world. And I agree, Mark, with you exactly. We've got to work to feed an ever-growing global population. And we're not growing a bigger globe, so that's less land to produce more food. And so, if that lab-grown meat becomes part of that process and it can become cost-effective enough and safe, then that's fine. But I see it as a full circle of life, and I believe that livestock production through gene editing technology will continue to be a vital part of food production globally.
Thanks, Donna. We have a question for Chloe now, or rather an opportunity for a response. The slide that Chloe showed regarding global regulatory was green for the US. However, I would argue that it is only true for plants. the approach being taken by the FDA for gene-edited animals seems very different from every other country in the world.
So just the clarification on the slide that I showed is indeed for plants. The Genetic Literacy Project, which is publicly available, and I'll put the link in the chat there for everyone, does also have a different slide and map for, I believe, microbials and for animals. So I'll put the link, but those maps are different.
Great.
A couple of people have endorsed the following question, which is to all the regulators. Executive Order 13874 asks for regulation streamlining. To what extent are the three agencies working together or separately as they respond to this order?
I could take a crack at that one. So the 13874 acknowledges that each agency has separate regulatory authorities, and those authorities have differences in what a regulation can look like. So there's going to be some differences in how the regulation is composed by each agency. That said, having gone through the regulatory revision at the USDA, we had tremendous input from the FDA and the EPA about our regulation. And we have discussions. There are some things that we tried to make more common between us, such as definitions. And so there is to some extent, there can be some commonalities. And likewise, the EPA is going through their PIP rule revision, and we have been giving input into the EPA. And through this process that has been coordinated by the Office of Science and Technology Policy, we're trying to establish as much common ground as we can between the various agencies.
This is Eric. I would second what Neil just said.
I agree. As I mentioned, I think the key is looking for ways to apply, as these guys have mentioned, those exemptions or places where we can use enforcement discretion to allow low-risk products to get through the process more quickly, more efficiently. Also ways where we can collaborate together. And I think we have a very good relationship, all three of our agencies, and are looking at different ways to do outreach to the public as well as work together. We work very closely with our colleagues and continue to do so.
Shall we move on to the next question, which is, what, if any, potential impacts on the U.S. regulatory landscape do you anticipate from the new USMCA trade agreement?
And that would be the U.S.-Mexico trade agreement. Well,
yeah,
or Tom, you guys sell to the consumers. There's that aspect, and then there's the regulatory aspect of whether or not we're congruent with our federal regulations and the Mexican governmental regulations, I'm guessing.
Yeah, I mean, we have moved some of our breeding stock into Mexico, and for the most part, I would get involved at that level. So to speak to actually the transfer of the food product and those regulations, I'm not familiar at all with that. But in terms of animal movement, both from the U.S. to Canada and vice versa, and then to Mexico, I mean, that's a very well-established process. It works very well. It's in Mexico in particular, they have an excellent process for pre-approving those animals, health testing and so on, and moving those in that direction.
I can chime in from a plant perspective because we do have very high expectations in terms of USMCA. In the US, as you've seen for plants, the regulations are very proportionate to risk, and there's a fairly straightforward process that we can follow. In Canada and Mexico, however, for gene-edited plants, the process is a lot more clunky, and so we're hoping that that will help maybe bring more consistency with those two countries.
All right, since we have a flood of questions, let's move along to the next. Heather, is it possible to get an food animal regulatory enforcement discretion without submitting an INAD?
And I'm assuming this question means food animal for food use, because we do have animals from food producing species that we have exercise enforcement discretion, which I presented. And the answer is yes, based on a determination of low risk, as I was mentioning. So under that case, it would be handled under what I was describing, the VMF file, and would, if we decided that the product was low risk and did not require an approval, then that could be done without opening an INAD.
Okay.
So, Neil, this is probably directed to you. Is it necessary that there should be no backbone coming from DNA vectors at all for the plants not to be regulated? What sort of genetic incorporations are tolerated? Removing promoters, selected markers, Cas9 as examples. What if there are some other segments? Are they checked? And we can remember the recombinetics polled cattle that had a plasmid inadvertently included in there.
Yeah, that's a great question. We have, like, as I tried to explain, we had two regulatory instruments in our new rule. One is the exemptions, and one is this regulatory status review. If you have vector DNA inserted, such as like a polled cattle, that would not qualify for an exemption, and you would need to come in for regulatory status review, which would give us the opportunity to address whether or not that foreign sequences created any plant pest risks. So it could get a non-regulation, but it would need to come in for this regulatory status review. We would need to look at it. You would not be allowed to declare you an exemption for your organism if you had that foreign D inserted.
Okay, so the next question is for Dr. Bonenblust and also Dr. Hoffman. Have your agencies determined who would be responsible for regulating engineered insects for agricultural purposes other than for mosquitoes?
If it's a plant pest, like we had a diamondback moth or a pink bollworm, then USDA would have a bite at that apple or that insect, however you want to describe it, and then EPA probably would be involved as well.
Yeah, so I think as far as EPA is concerned, we haven't made a decision on that as far as what our role would be at this time. So,
and there's some insects that I'll have to look at the question again, but there are some insects that FDA regulates as well. So we would only be involved, the USDA would only be involved if the insect was a plant pest.
and as of now, EPA would only be involved with mosquitoes in the population suppression realm.
So this might actually involve FDA as well, if it's a food.
You're talking about an insect?
Well, I'm talking about that question. Yes, an insect, though, that is affecting food, rather than
like crickets.
Yes.
Right.
Well, or even the diamondback moths that you mentioned.
Oh, okay. That's a good question.
Or or one of these fruit insects that directly is interacting with what you put in your mouth.
Yeah, I don't know that FDA had any involvement, but maybe they do. I think that's a question for the CIFSAN. I don't know if Heather knows.
I don't know if I can answer that question. Sorry.
Part of where this is going is Tom and Donald, as the people who would be buying the animals at least, have noted that they're under really tight margins. And one can imagine that if you have to meet the requirements or required documentation for two agencies that have different requirements, that this is really raising the costs and making it perhaps prohibitive for some things to be passed on to Tom and Donald. Any thoughts?
And I think that's part of what the executive order is trying to address, and the coordinated framework is that redundancy and increased regulatory burden. So I think we all agree that having redundant processes is not productive and doesn't help the end user, which would be the producer in this case. So we would, prefer to reduce that as much as possible.
Heather, this is Donald, and I want to just say thank you. I appreciate that perspective. And to me, Tom and I are just part of the food chain here, but really the consumer that eats the food to me is the end user that is the net benefiter of this type of technology. And yes, we're ready to use gene editing technology right away, but with the risk of and the timeline that it takes for these products to get approved and the cost, is scary to consider making that investment with the unknown at this stage of the game. But we're ready as soon as we deem it to be reasonably affordable and approved in a timely fashion.
I hear you, and we absolutely agree with you.
Thank you.
Mm-hmm.
So we probably have time for one more question. Do you want to choose one out, Perry?
No, go ahead. You probably have it in mind.
Well, this top one is very long. In the instance where a food animal has the characteristics to argue for very minimal risk, for example, contains an IgA that introduces an allele existing in the animal species for hundreds of years, that has a clear recognizable phenotype and no detectable unintended changes. Why would this animal still need to proceed through the INAD process for food use authorization instead of just receiving a DE decision? What is remaining risk that is needing to be mitigated?
So I need to clarify, there's a lot of confusion here about the different processes in this question. So when we're making a decision about commercialization of a product, that's different than a decision about an investigational animal being introduced into the food supply. So a decision regarding commercialization, as I mentioned, could either be handled under an approval, which would be handled under the INAD, or we could make a determination that that product poses minimal risk, and that would be handled under enforcement discretion, and that would not require an INAD. For an investigational animal for which there's not a lot of data generated yet, usually it's like 1 or 2 animals, an investigator wants to put that in a food supply. By law, that has to be done. That's an investigational action that has to be done under the INAD process. So by law, we're restricted to that process.
So Heather, this is directed to you, but it might apply equally to Neil and Eric. If another country, for instance, Canada, approves a gene-edited food animal, crop, whatever, how will imports of live animals, seeds, or germ cells be dealt with?
Well, if it was a GE crop, for example, that would fall under our regulation, it would, if they would need to get regulatory, if it was exempted, they would need to even come to us. If it was not exempted, they would either need to have a permit for moving it into the United States, or they could ask for a regulatory status review and would be able to eventually get a response. So I imagine in that case, if it was not exempted, they would probably come in for a permit, very much like what's being done now.
And to add on the food animal side, so there is a process that currently exists, which is called an import tolerance. And it's essentially a safety assessment, a food safety assessment that's performed with minimal data to determine whether or not it's safe for those animals to be introduced. In terms of collaboration and accepting data from other countries, that is something we're very interested in pursuing to the extent we can under our laws. And we're looking for opportunities for collaboration with countries like Canada, either through some sort of simultaneous review process or some sort of simultaneous or joint approval. So that is something we're looking into.
And from the pesticidal perspective, we're a little bit different. We do have the same avenue of an import tolerance that Heather mentioned. So if it's grown or applied to a crop, the food can be imported under an import tolerance, but they would have to come to us initially, and we'd have to do a review for food safety, much as FDA does. On the other hand, though, if it's something that's intended to be sold or distributed as a pesticide and used as a pesticide in the United States, they'd have to come to us to get a registration. They wouldn't be able to import it for use in the US without a registration unless it was something that is already exempt by our regulation. So, and that's because FIFRA is a licensing statute. So if you're actively doing anything that would fall under FIFRA, you need a registration for that.
Okay, we're a little bit over time. Thank you all. I think we've accomplished at least some of the missions of this, and we have some flash talks coming up. So I encourage you to go on to the next session, and we can continue later. Kit?